Example 2. Check to see if the solution m equal to 1 is correct for the equation 2m subtract 3 equals 5. So we're checking m equal to 1 for the equation 2m minus 3 equals 5. So we're going to do a comparison of the left side to the right side. The left side is 2m minus 3, the right side is 5. When I sub 1 in for m, I get 2 times 1 subtract 3, 2 subtract 3, negative 1. Well, now if I compare the value of my left side to my right side, they are not equal or balanced. So left side does not equal right side, and m equal to 1 is not the solution for this particular equation. Example 3. Check to see if the solution a equal to negative 2 is correct for the equation negative a plus 5 equals 3 minus 2a. So we're checking a equal to negative 2 for our equation. We're going to split the equation into left side and right side. And remember, it's the equals that divides our two sides. So the left side in this case is negative a plus 5. The right side is 3 minus 2a. I'm going to start with the left side by subbing in negative 2 for a. So negative 2 becomes positive 2, and I have plus 5, which gives me 7. I also have an a on the right side, which means I have to sub in negative 2 over here as well. 3 take away 2 times negative 2. Well, a negative times a negative is a positive, so I end up with positive 4. 3 plus 4 is 7. So when I'm done, I do indeed end up with a balanced equation. 7 equals 7. Left side equals right side. Therefore, a equal to negative 2 is a solution to this problem. Using algebra tiles. So now again, we can use algebra tiles in order to solve equation. So to solve an equation, the goal is to isolate the variable or get the x all by itself on one side and to have a numeric value only on the other side. So we're going to use algebra tiles to solve x plus 3 equals negative 1. So first we're going to model the equation with tiles. And then second, we're going to add tiles to both sides to keep it balanced, and then applying zeros so that only x remains on one of the sides. Okay, my left side is x plus 3. My right side is negative 1. And they are equal, so they're in balance. So if you think about this as a scale, I have to keep it in balance. I want to isolate x over here or get it all by itself. So I want to get rid of the 3 red tiles. 3 blue tiles will cancel out my 3 red tiles, but I've just thrown the scale way out of whack. So I have to add 3 blue tiles, the exact same thing, to the other side. This balances this, this balances this. Now I can apply my zeros. There's a 0, there's a 0, there's a 0. So I have my x there, I have my negative 1. But these are still there as well because they didn't have any red tiles to cancel with. This is gone, this is gone, this is gone. I'm left with x. Everything here had to stay. So we can see x equals negative 4. So solving equations with algebra tiles is not something that's commonly done because we don't carry tiles with us. But it can be useful for demonstrating the truth that you have to apply the same operation to each side when solving an equation. I had to add 3 negative 1 tiles here to isolate my variable, so I had to add 3 negative tiles over here as well to maintain the balance. So if we look at it algebraically, x plus 3 equals negative 1. We added negative 3 to both sides, negative 3 and negative 3, to cancel this out. When we do that, we get x, because 3 subtract 3 is 0, equals negative 1 subtract 3, negative 4. Solving algebraically. So most equations cannot be solved by inspection. More complex equations always can be solved algebraically using the rule, when solving an equation, apply the same operation to each side. So remember, the opposite operation of adding is subtracting, and the opposite of subtracting is adding. The opposite operation of multiplying is dividing, and the opposite of dividing is multiplying. So let's solve x subtract 4 equals 17. So we want to isolate x. So we want to remove the subtract 4 on this side. The opposite operation to cancel out the subtract 4 is add 4. But we have to add 4 to both sides to follow the rule. When solving an equation, apply the same operation to each side. So I add 4 there to cancel that out, but to maintain equality I have to add 4 over here as well. So I end up with x equals 21. This cancels out to be a 0, which is what I wanted to happen. Over here I have to do the math. 17 plus 4 is 21. To check our answer, we're going to check x equal to 21 for x minus 4 equals 17. We do our left side, right side check. X minus 4, 17. 21 minus 4 is 17. 17 equals 17, so left side equals right side, so x equal to 21 is a solution. Example 2. 5 plus x equals negative 3. 5 is what we want to cancel out or get rid of, and it's a positive 5, so it's being added. The opposite is going to be subtract. So I'm going to subtract 5 from both sides. So at the end of this side I put a subtract 5, and at the end of that side I put a subtract 5. That maintains the balance. I've done it to both sides. I'm left with x, because 5 take away 5 cancels out to a 0. Negative 3 take away 5 is negative 8. Our solution. Always check. Left side, right side. 5 plus x, negative 3. 5 plus negative 8 is negative 3. Left side equals right side, and x equal to negative 8 is a solution. Negative 14x equals 7. We really have to think about what the operation of this negative 14 is. Here, x is being multiplied by negative 14. We are not subtracting 14. So we have to use the opposite operation of multiplication, which is division. So we're going to divide both sides by negative 14. Negative 14 divided by negative 14 is positive 1. We've isolated the variable. 7 goes into itself once, and 14 twice. So this is a fraction because we can't really do the division, so we reduce it to lowest terms. And when you have a positive divided by a negative, the answer is negative. We're going to check. And sometimes you can use the decimals when you check your answers because it's just a check for your own purposes. So left side is negative 14x, right side is 7. Negative 14 times negative 0.5 gives positive 7. Left side equals right side. X equal to negative 0.5 or negative 1/2 is a solution. X divided by 3 equals 17. So when we see a fraction, we want to get rid of the denominator. And remember, we've talked before that fractions are divisions waiting to happen. So the opposite of a division is a multiply. So we're going to multiply both sides by 3 to get rid of the denominator. Three times x over 3 equals x. We can work through it as fractions, or you can look at it, I have a multiply by 3 and a divide by 3, and they cancel out. 3 times 17 is 51. So let's check x equal to 51 to see if it is the correct solution. Left side, right side, x divided by 3, 17. 51 divided by 3 equals 17. Left side equals right side, and x equal to 51 is a solution.